Welcome everyone to this latest Zero Carbon Mine webinar. We discuss everything around the decarbonisation of the mining industry, and today we're lucky to have Ottomar from Boliden, who's going to run us through some of the things they've been doing with the decarbonisation of their projects, and whether or not, underground or surface is, will win the race towards a zero carbon mine. So if you have any questions, please type them into the Q&A box and we'll try to get them as we go. Other than that, I'll hand over to Ottomar and we'll go from there. Thank you.
Thank you. And thank us everyone for listening in, and thanks for inviting me. Great to share how we are working with mine decarbonization in Europe. Just very quickly about myself, I've been working for about 7 years for Boliden right now, and in the past 2.5 years in the role of coordinator for climate and energy. So it's a bit my job to keep an overview of our project and develop our roadmaps towards our 2030 targets and toward our net zero target. And next to that, I'm also responsible for some of the research we do in climate-related areas, for example, carbon capture and mine waste, etc. But I won't discuss that today. Today, I will solely focus on the actual decarbonization of our operations. What I wanted to go through with you today is basically a question: how quickly or how reasonable is it to assume net zero, and within a time span of maybe 20 years? I'm totally convinced that at some point we will reach net zero. I will get back to that a little bit later, why that is. But the big open question is when, how, and especially in the near term, how feasible is that? Of course, we can always discuss significant reduction steps, for example, energy efficiency, or maybe some, let's say, conveying systems or things like that. But today I will really focus on these things that really are new steps that we will need to get to a fully zero carbon mine. To spoil a little bit, I would say that open pit mining is simpler in the sense that there's fewer things to think about, but it's probably harder to decarbonize. But I will go through that. Basically 4 parts, just first in general about Boliden, so you have to have an idea about our climate targets and bit of a prioritization there. Then our study on what actually are our current emission factors, then how we think we can deal with that, and then finally some more cost based or feasibility based comparison. Just shortly about Boliden, we're both a mining and a smelting company. All of our operations are in Europe, or in the EU specifically. Founded in Sweden and still with most operations in Sweden, but also with quite a large presence in Finland, and then also in Norway with a smelter and 2 mine sites in Ireland and Portugal. We have a rough annual revenue of around $10 billion and around 8,000 employees. And Boliden's vision is to be the most climate friendly. I made it bold because it's a central part to our company and respected metals provider in the world. And I will go through how we try to live up to that vision. Specifically on the climate targets, we got certified a few years ago, 2 years ago, by the Science Based Targets Initiative as the first and so far only mining and metals company in the world. The purpose of this certification is to make clear that we are expected to live up to the requirements of the Paris Climate Agreement, and also to have that externally verified. And that means that we set a new baseline year, 2021, and from there we do our maths, and then in line with what would be needed to reach that climate targets, Paris climate targets. That means that we need to go down 42% in scope 1 and 2 in this time frame, and minus 30% in scope 3, I won't go through the scopes. I guess you will roughly know what they entail. And then also that we need to be net zero by 2050. And then, as already hinted at, I think that 2050 target is probably easier than that 2030 target. But I will get back to that. To give an idea of our emissions, we have roughly 1 million tons direct and indirect emissions in scope 1 and 2, and then an estimated 3.5 million tons in our supply chain, scope 3. Yeah, this is, I think, a good principle to both delineate our scope of our discussion today, and also, I think, a good manual on how to tackle decarbonization. I call it Maslow's pyramid of decarb, based on what sequence of decarbonization measures are the smart way to go, and in a way also the only way to go. To start with, you start with a scope 2, because of course, with your scope 2 measures, because if you don't do that, well, then it's also very hard to, I mean, you can electrify, but then that won't make any sense from a decarbonization perspective. So if you have successfully fixed, so to say, scope 2, you can move to scope 1. And that is because you have the most control over it, but also because both your scope 1 and 2 have quite a significant impact in scope 3. So if you don't feel very comfortable with scope 2 and 1 yet, maybe it's not the time yet to move to scope 3. That's what I want to say. Then scope 3 is very complicated, and for most mining companies also much bigger than the scope 2 and 1. You can roughly distinguish it in 3 categories. The upstream part, that is, I would say, the next step, because usually it's easier to control or influence at least your suppliers, and also because it's part of your carbon footprint of your product. So it's probably the most important subtype of scope 3. Then the midstream, roughly about getting to work, your business travel, etc. You could argue that should be part of your carbon footprint, but I would say it's less important than your proper upstream of like your goods and etc. And then finally, downstream. I'm aware that downstream is for most mining companies actually the biggest part of scope 3. Luckily, I would say as Boliden, that is not so much the case for us, as we also have smelters, and we also have a climate action plan in the smelters going on. I won't discuss that here, but that means that I usually can completely neglect, or almost completely neglect, the downstream part of scope 3. So roughly speaking, I would say, given that in the Nordics, the electricity has historically already been very much decarbonized, that is not my key area. I would say our key challenges are in that scope 1, and then in that upstream, maybe a little bit of midstream. Okay, then to start with how we started working with tackling their carbon emissions and moving to that zero carbon goal. After we set our targets in 22 and started doing all these studies for 21, we did a very detailed study of all our operations and where all emissions come from, so in all scopes. And basically the summary of that I will go through with you before we can discuss how to deal with that. Of all our emissions, so in scope 1, 2, and 3 for all of our mines, we established that 39% of them are coming from diesel, so that's both for underground and for surface. I will split them later. And then that of that 39%, it's very much dominated by our, specifically our open pit mines, but the hauling, and then around 10% with mucking, both in surface but mostly in underground mines. So this is, of course, our most important area. Electricity, as I said, luckily for us, in the Nordics at least, we have very low carbon electricity. So all sites there have a very low emission profile when it comes to scope 2. However, our operations then still in Finland has decarbonized quickly, but also in Ireland and Portugal, have quite significant emissions, and probably that's the case for you if you are in an area without low carbon electricity, and probably your electricity is your biggest part, but for us it's about 25%. By the way, the green number in the top is counting up, just to give you an idea of what share of emissions we're covering, but we moved from 39% at 25%. So now we're at 64% of our emissions. This is a bit more distributed, but it's a lot about milling. As you will probably know a bit about our mine ventilation and conveyors, etc. But again, a lot of milling, a lot of crushing. Then and hard to fix category, explosives has some scope 1, but mostly scope 3, roughly about 10% of our total carbon footprint. We'll get back to how to work with that. Then shotcrete, of course, only relevant for underground mines, but we use quite a lot of shotcrete, and that is mostly then the cement that causes these emissions, but also some of these additives and fibers, etc. Then backfill, again, only underground, mostly consists of the cement. Of course, the waste rock is relatively low in emissions. We also use some slags as replacement for cement, but they typically have very low emissions. Then our wear and spare parts, estimated about 4%. It's a bit harder to estimate than bulk goods, but a few percent still. And then we, of course, discuss, the drill bits, bolts, etc. Let me just see. Then we go on to processing chemicals. This is quite a complicated area since, of course, as you know, in mineral processing, you use a lot of different chemicals. The biggest category is for lime. We use lime both for processing in the mill, but also for water processing after the mill. So an important category. We use metal sulfates for our sulfidic deposits to process them. And then we have older flotation chemicals than lime and metal sulfates, and some minor frauders, collectors, etc. Finally, or almost finally, the concentrate transports. Luckily for us, they are very low. And that is because, as you saw on the map, Europe is not that big. And then most of our operations are focused in the north of Europe. So we have relatively little shipping. Most of it for us is trucking for our sites that are not connected to the sea or rail. Then the remainder is a topic you might wonder if you want to discuss at all. It depends a bit. For example, the secondary fuels, they can be big for one specific site, and I would consider them relevant. But for example, office stuff, as I call it, well, that's of course not really our business, so I won't go into that at all. Okay. Then I will move to what we've thought of to tackle these emissions. All of these projects in themselves are worth another hour probably. So unfortunately, I will just mention that we have it. There's not so much to discuss in detail there now. But we've managed basically to find options, at least that are technically possible, maybe not commercially, but technically possible for all of these emission sources. So I'll go through that. Well, for our biggest category, diesel, you're probably very familiar with that. I won't focus too much on that since there's very good electrification specialists everywhere. Just as a general strategy, we focus mostly on the trucks, both in the open pits, both in the public roads that we operate for the concentrate transports, as well as the underground trucks. Why is this? Well, as already said, about 75% of our emissions are from haulage, and that didn't even include the transports to the smelters yet. So trucks are just the most effective way to decarbonize. We are, however, also involved in some electrified mining equipment. Luckily, as a Swedish company, we have Sandvik and Epiroc next door. So we do some of these trials. Probably our most ambitious project in that area is the Boliden underground mine. You may have heard of that, that we made an all-electric underground mine. It's just a small mine, but mostly to show the potential. Electricity, again, not a big focus at all, basically, for me. We have two jurisdictions where we operate where historically the emissions are quite high from electricity, namely Portugal and Ireland. In both these places, we have solar projects. These are, in fact, the most lucrative projects that we actually have, because they are developed by other parties, so there's no capex involved, but they are developed on our lands, and feed it directly into our mines, and they will save us on electricity and at the same time decarbonize. So it's a very, again, think back about the Maslow's pyramid. If you have nothing else, then that's the way to go. For that reason, also our electrification efforts in Portugal and Ireland are still fairly limited. Only once we have very low carbon electricity will we move to electrifying that. Good to know in general, we expect consumption of electricity to go up. So even in Sweden or Finland, it might become a challenge at some point. This is partially because the mines get deeper and bigger, etc., but also since the electrification will require more electricity. I saw a question from James. Have you considered using biochar in mining operations for resource recovery media, replacing activated carbon processing soil remediation? Yes, we have been looking into that. Actually, that is part of the climate research I'm involved in, so it's not exactly the operational side, it's more the research side. But we are in a project that is financed by the EU where we look at the combination also with mine tailings, for example, to store carbon in that, and then biochar could apply to that. That's one angle, and the other angle is, of course, in the processing. It's a very minor category if we look at our operations, however. Cement then, our biggest category, maybe one of the, in my honest opinion, most interesting projects. Our smelters are able to produce slags from, or they of course do produce slags, but to mill them in such a way that they become good additives to cement, and they can replace, well, we're right now researching how much, but let's say 60% of cement. So in other words, you can very significantly reduce cement usage, and will actually improve the quality, so the binding properties of the binder. So especially in backfill, we'll start soon have trials to use this internally produced cement. So that will make a very significant contribution, at least halving emissions from backfill, and in longer term from shotcrete. However, it's never possible to fully replace cement, at least not yet. So there we need to find something else. It probably lands at carbon capture and storage. We'll get back to that. Then in shotcrete, we use a lot of shotcrete that we would not need to use, basically because of overspraying. So we've also been checking shotcrete scanners to reduce shotcrete. But again, to make it fully zero is impossible, I would say, without carbon capture in this case. Explosives then. We started trialing hydrogen peroxide explosives a few years ago in underground mines. That works quite well, I would say. There is, and these hydrogen peroxide explosives, they have about a 90% lower footprint. The only footprint that is remaining is from the fuel. Theoretically, you could even replace that fuel with a biofuel. So then you could bring it to zero. And that is very significant because explosives are a significant share of our emissions. However, there's a huge caveat there, and that is that so far we're not able to leave these explosives too long in their holes, and they do not work very well with very sulfidic rocks. So that is a big challenge, because for our underground mines that don't have too sulfidic rocks, they work well, but for everything else, they right now don't seem to be not effective yet. Then a second problem there is that they are quite expensive, but I will get back to that. When we speak about explosive use per blast, larger scale underground mining methods are typically use less explosives, and we also have been looking at using electronic detonators, for example, to reduce. But again, this is just reduction measures. To make it fully zero, there seem to be no options other than these hydrogen peroxide explosives that continue to be developed. So hopefully it will get better. So the processing chemicals, We are actually starting to produce our own metal sulfate, so then at least we know exactly the carbon footprint, and if the mining would be zero, then also these metal sulfates will be possible to be zero with our own smelters. For lime, at least in water treatment, we've seemed to have found a good alternative. In the Nordics, heat plants typically use a lot of wood waste, and when that is burned, the waste product is right now just dumped. So it costs the energy companies money, but it seems we can use that to neutralize water, to bring the pH to the required levels, and also to catch some metals. So that could be a good alternative. Unclear yet if we can fully replace lime, but at least a good chunk. What are the challenges of using HBO of HBE explosives, and what is the impact on its efficiency? So the challenge again is mostly that they have difficulties being in a blast hole for more than a few days. So that makes it impossible with open pit mining that you do, of course, in large blasts. And then if the rock is very sulfidic, it reacts. So that's the big challenges with them. Otherwise, it works brilliantly. You need a little bit more of the explosive, and that's one of the reasons it's also a bit more expensive. So in that sense, it's less efficient. But that is not a big difference. And on the biochar enhanced concrete, no. Maybe we can look into that later, but no, we have not looked into that yet. Concentrate transports, well, that's again a lot about electrification. In some cases, we could move some more stuff to trains, and we actually trialed some sails on ships. But again, shipping is not very significant to us, so I will leave this. Then, maybe the most important part, the comparison. As the title of the presentation, I chose basically comparison between underground and surface mines, because it highlights some of the challenges that I think are very typical in decarbonization. In the graph, you see 6 of our sites. Kevitsa and Aitik in light blue. They are both open pits in the north of Finland and Sweden. And then the other ones, Tara is in Ireland, and Kristineberg and Garpenberg are in Sweden. And they reveal a lot about current status, at least, of decarbonization. This is numbers for the year 2021. It's very clear that open pits have much higher emissions per ton of metal. The unit is per ton of metal. And that is quite surprising. I want to point it out, given that, for example, Ireland has much more high carbon electricity than Finland and especially Sweden. And also the transport distances, especially for Ireland, but also for Kristineberg and Renström to the smelters, are much bigger. And still their emissions are much lower. Yeah, why is that? Basically, in the end, it's about grades, right? If you need to mine less for the same amount of metal, and you don't have all that stripping and overburden removal that you have in open pit mining, you can mine much more efficiently and thus more low carbon. So it's basically a question of efficiency. You also see a difference between the underground mines itself. Garpenberg is by far the lowest carbon mine, and actually the newly acquired Zinkgruvan mine in Sweden is even lower carbon, and that is mostly because they use larger scale mining methods. Tara has much higher emissions, but that is mostly due to electricity that is much more carbon intense in Ireland. For the open pits, the difference is only also due to electricity. Another caveat that I think is important to take into account, and that sometimes is very hard to explain to other stakeholders that are not into mining, is that especially our open pits fluctuate a lot in emissions per year. That is because, well, as you know, sometimes you will have more pushbacks to do, sometimes not. Where the huge dam project in Aitik mine, for example, then pushed up emissions, and after that they come very quickly down again. So they move a lot in emission intensity, whereas the underground mines are much more stable throughout the years. So just to sketch a bit the dynamics to start with, much more efficient with underground mines, but also more stable. The question is, how will that change towards the future? So basically, I try to give a rough estimate of the cost of our decarbonization measures. There's a lot of caveats here. Of course, there's a huge difference between specific projects, so it's very generalized. I can also not give very specific numbers for secrecy reasons. And then also, there's some speculation in the estimation for 2040, of course, but it's mostly to give you an idea of the measures that we already can fully implement today and the measures that are likely to be implemented going further down the road. So right now, as I said, the solar energy. Oh, one important thing to mention also, when I say costs, I don't mean OPEX. OPEX is quite attractive, for example, for electrification measures. But if you discount for the capex, that becomes less good. So it is basically like an annualized cost and then distributed per ton of CO2 saved. So again, for us, our solar energy projects are the most rewarding, so to say. Already today, there's no expectations it will change much. It could even could become a little bit less good, given that the overall grid is also decarbonizing. So maybe then the cost advantages will get less. But regardless, it seems right now it's always a good option for us. Mine heating, a very specific Nordic problem. We have mines that are very cold in the winter, and that means then you get ice in the ventilation shafts. So you need to keep that heated. And for these smaller underground mines, it's actually a very significant share of their emissions. So we have tackled most of these things already, and we'll do that within a few years for all sites. So that's also a no-brainer. Then I mentioned these trials with lime. They seem to be very promising, and it's a cost saver as we can get these materials for free. Then the metal sulfates, same thing there. It is in some cases cheaper to import it from China, but at the same time, the uncertainty around supplies makes it quite attractive for us to produce them ourselves as well. Then for the binders, right now we don't have anything there for the slag from our own metal sulfates. But we get some of the material from some steel companies in the area, some steel slags. We want to replace that with our own slags, and that would actually be a profitable affair as well, even without a carbon price. And then we move into the more less attractive areas right now. As I mentioned, we also look into passive carbon capture and storage that we could do ourselves. That would be quite cheap compared to other ways of carbon capture and storage. Renewable fuels, quite often questions about that. I just want to put that there. It is not too expensive right now, although of course it's never profitable. But we expect that to become worse with the years as more companies may not have alternatives to fix their emissions if you have a hard to abate product. And then probably we in mining are more, or for us it's probably better to move towards electrification. So we expect the cost to increase because of higher demand there. Open pit mine electrification currently, for the most part, not commercially available yet, as you will know. However, moving fast, so we expect that to become quite profitable down the road. The question is how fast. Then steel, there's some projects in Sweden in the way to make fossil-free steel, but it of course will always be more expensive than blast furnace made steel. However, there is with recycled steel, etc., a limited price premium. Carbon capture and storage, always expensive, but important in that sense that for some articles it might be the only option. Then again, hydrogen peroxide explosives, very expensive right now, but that's also because it's on a very small scale. So we expect that to become much better down the road. Then equipment electrification of different types. Typically, the public road trucks are getting online now. but we see underground mine electrification is still very expensive, unreasonably so, I would say. And the open pits, we see mostly good options from China, but otherwise it's still very hard to get. As the overall trend, we expect electrification to become cheaper, not too big changes in other areas. The two red lines, by the way, are the current price in Europe at minus 50 euros per ton then. And that's also expected to increase when Europe tightens these budgets, these carbon budgets for every year. And probably that price will then be set by either biofuels or carbon capture and storage, as that is the measure of last resort, so to say. So that's the range in which we think. So in other words, the more significant measures are not profitable yet, but we see that changing fast in some areas. Well, getting back to the main question of this presentation, how will that then translate to the surface versus underground mining? I already went through all the emissions. If we now look specifically at our two surface mines, how they have the distribution of emissions, well, half of it is diesel, so the bulk there is diesel. Then there's some electricity, there are some explosives, and that is the vast majority of emissions. That's around 80% or more. So in other words, it's quite simple to make a very significant cut there. Simple in the sense that we know where it's coming from. Hard maybe in practice. The remaining emissions, if we now assume that that is possible to fix, so explosives, that's a bit on the edge, but lime, fossil-free steel, etc., will be quite expensive as far as we can see right now to fix, or at least it will not be a lucrative affair. So that would, if we make a very rough back of the envelope estimate, maybe add around 50 euros per ton of metal. So that then it depends a lot, of course, what metal we speak about, and what grades are, etc. But to give an idea and to make the comparison with underground mining. But I would say the main question there is, of course, when. Pretty sure that it will happen just because of the physics. But when will the electric open pit trucks be available at a large scale and also in a cost competitive way? That I would say is the main question to answer there. Otherwise, there is quite some overlap with the underground mine challenges. So moving to the underground mines, you immediately see it's the colors are the same, but you can see it's a much more complicated picture. Electricity is still quite high, and that is because Ireland, Portugal. But if we think away the electricity, then you will notice that cement is the biggest category, and then a close second, diesel as well. And then the other categories are quite similar. It's a lot of bulk goods. So it's explosives, it's lime, it's cement, etc., etc. As for the diesel, just to tick that box, it is definitely possible. We showed that in the Boliden project in northern Sweden at a smaller scale, but still. It is, however, very expensive right now. So it's not something you would right now want to do at a large scale. And then, let me see. Yeah, and then all the others are basically some kind of bulk goods. And that's actually where we've put a lot of our own efforts. Of course, the electrification has always been an important topic, but also a lot with OEMs, where we put a lot of our own focus in all these bulk goods. Cement, as I already discussed, lime, then the explosives. We have a factory on our own site making these hydrogen peroxide explosives, these internal metal sulfates, and then maybe, like the biochar or some other bio-based chemicals. If that would work as well, there's very little remaining for the underground mines to become very much no carbon. Again, I think the electrification is a very safe bet that will manage that, given that it is already the case in 5 of our 7 sites. The electrification, it depends a lot on what vehicle you're looking at. We see right now in the public road trucks and also the personal cars that it seems to become definitely feasible. The large open pit trucks, as you know, there's a lot of OEMs from China that seem to be able to do that competitively. But a lot of the underground equipment is still unreasonably expensive, and especially the loaders seem very hard to fix. So that's the challenge for the electrification. However, if that works and these promising R&D projects work, we expect only around 10 euros per ton of metal that will remain. So then moving to the conclusions. Right now, there's no question underground mining is way ahead. Not because it's necessarily more brilliant technology, but because it's just typically how much higher mine grades. And then especially our large-scale underground mines are already very low carbon today. The complication, however, is very much with underground mines, because what you could call the significant emission sources, so that are taken into account more than 1% of our total emission profile, are 19 emission sources versus 9 for the surface mines, where they also very much focus underground mines on just diesel, essentially, and explosives. However, many of these extra, so these bulk goods, so these cement, shotcrete, etc., and some of the wider lime, and in our case, we also have more complicated ore bodies underground, so the processing is a bit more complicated. If we manage to do that in-house, that will work well. Then there will always be some emission sources remaining. That's important to highlight. Cement, for example, we can get a very long way using these slags, but we cannot get all the way. So if you want to get that zero carbon, so far we only see carbon capture storage as an option there. A bit the same with explosives. So far, there's still 10, even if the hydrogen peroxide would work, 10% remaining. So there is these examples. Same with lime, we can reduce a significant chunk of lime, but there will still be the need for some actual lime. And as you know, when you produce lime or cement, you will by definition release CO2. So then there's only one option if you want to make it fully zero carbon. So I will not give you a straight answer, but I would say there's 2 key questions that you can maybe answer yourself, and then you can also answer the core question of the presentation. How quickly can mining fleets be electrified at a cost-competitive basis? And of course, will that be quicker in service or underground mines? I believe next week we have a topic in the same series about just that, or at least about difficulties with electrification. But so far, they both seem to have their own challenges, mostly the price levels underground and the availability in the surface. So what will come first? And are we able to translate these very promising research projects that we currently have for these chemicals into actual operations? That's the second question. If the answer to both is yes, then I would argue that the underground mines will stay ahead. And that was all from my side from the presentation. Thank you for your attention. Do you have any questions?
Yeah, if you have any questions, please just type them into the comments box, and we'll chat box, and we'll try to get to them. Yeah, great presentation. Got an overview of all the different projects. I suppose it does make it easier or simpler with it all being Europe-based. Generally lower emission electricity. I'm curious, is your cost benefit of those reduction options. The electrification is sort of well down the not so good end, but you're still trialing a lot of those technologies on the site. So isn't it right? So I suppose it's
it's a good point. And to be honest, we're a bit disappointed in electrification. We thought much more of it 3 years ago, just because we would say the physics should speak for itself. And we are trialing, and we're still convinced it will be the future. But so far, it seems that maybe OEMs are trying to get some extra money out of it, to put some premiums on it, more than maybe is justified. And then also, the rollout is not as fast as we would hope. Again, I mentioned the Chinese OEMs. Typically, we didn't do any business with them, but if you look there, they're well ahead. So we see it is possible. But right now with the Western OEMs, it's not as great. But I would say it's unavoidable because well, we know the cost of batteries, and the vehicle and the engines themselves would be cheaper than a combustion engine. So in terms of charging and like all the underlying infrastructure, we're trying robots with ABB to do the charging, things like that. We have a trolley system in place that works well at one side, not as well on the other, but we know the technical fixes there. So we believe in the underlying infrastructure and everything like that seems to work. It's right now mostly a question about battery prices.
Right. So that, yeah, the technology probably hasn't come along as quickly and as well as it probably.
Yeah, and the scale. I mean, theoretically you can buy a lot, but you will need to pay a very hefty premium, and we try to make it cost competitive. And I also genuinely believe that, as you saw these cost overviews, almost all measures we expect almost all of them, except for like carbon capture or biofuels and the explosives, to be competitive. And a good thing to mention, that's why I put the expected carbon prices for Europe there. If there will be a carbon price, then some of these measures, even when they're below zero, will still be cost competitive, just because you otherwise will have to pay for that emission right. So that also may make it feasible to implement projects that are even below zero.
Right.
But yeah, I would say carbon emission rights are not even necessary for electrification in the long run to get back to electrification. Yeah.
A couple of questions from Sarah. Yeah. One of them's what breakdown maintenance problems are you seeing with your underground electric loaders? Are they with both major OEMs?
Yeah, we tried. So at least for the underground, the Swedish OEMs, we have good collaboration with. So both Sandvik and Epiroc. For the loaders, and actually it's good also to mention. Then we speak specifically LHDs. We also use a lot of wheel loaders, typically from another Swedish company. They have some problems usually that. All sorts of problems. It's just sometimes that they don't last as long. Sometimes they are not very reliable for whatever reason. And I also would understand on a theoretical basis, like it seems the hardest challenge, right? Because you need a lot of power, need to move around all the time. I mean, the truck is easier to just swap or also drives down a lot downhill. Like the power usage is not as high. So we've seen different problems with different suppliers. They are working on it, so it will come, but it might be the last thing to come. I would say today. Yeah.
Right. And another question from Sarah. I suppose why do you think batteries are still so expensive, particularly battery as a service? Because is it because OEMs are unsure about how long they'll last? There's still some unknowns there.
It's a good question. I would say for if you look, for example, let's compare it with the personal car market. There they have gotten much cheaper, and so sometimes I just wondered, why would you not just put like right? If you compare an underground mining vehicle, for example, they use very little fuel. Typically, for us at least, these vehicles drive about as much as a personal car would per year. Like they use about as much fuel, just because they tram a bit, a few kilometers maybe at the most per day. And that's about it. So they're heavy machines, but they don't tram that much. So I would say on a theoretical level, I don't see why it would be a private car battery that are quite cheap, maybe let's say $20,000-$30,000 today. However, typically these OEMs charges around $500,000. So it's a whole different scale. And why is that? Well, maybe just to make profit, I don't know. But it is also because they choose to develop everything themselves. It's very small scale. So it seems the OEMs maybe need to move to more mass scale, mass production, and then probably it will become cheaper. We're convinced of that, but so far the OEMs are not.
So slower than you probably everyone's expecting in a way. And just comment question from Brazil. Are you able to share this presentation?
Sure.
Yep, and talking about autonomous and electrification underground. It's a significant reduction in ventilation related capex and opex, meaning lower carbon footprint. So yeah, can you comment on that? Like, you're looking at automation and that sort of side of things?
Just on the automation, even in surface, that will reduce, just because robots are more efficient than humans somehow in driving. We saw that in unlike an automated track, where we have one small pit that we in ITIC mine that we completely automated, and that they have lower energy usage. But I guess you're pointing specifically to the ventilation. However, so for energy usage, you're definitely right. For the emissions, I mentioned the heating in the beginning. That would be a lot of emissions, but they got to almost zero now because of these heating electrification measures, like heat exchangers, etc. And then the electricity again for us is pretty good. So I mean, sure, it's a good measure. It will be cost saver. It will be energy saver, but it may not be a big saver just in CO2. Again, we should do it. There's very good reasons to do that, but maybe the carbon footprint effect will not be as big.
Right. But something else that's in the mix of seeing what we can get. Anyone else have any more questions? That might be just about reaching the end, but plenty to digest seeing what lessons we can take out of it for different parts of the world, where it might be, different conditions from what you've got there. Probably makes it easy with the lower carbon electricity and sort of some of your integration with your other operations. But
again, I just want to say, because of course we're in a luxury position there. However, if you speak relative reductions, our big champions are not our Nordic sites. They are Portugal and Ireland, just because they come from a much higher level. So it depends on how you see it. If you want to make the big gains, it's probably better to be in a high carbon environment, strangely enough. Just want to get that as a comment. But sure.
It's probably there's more low hanging fruit, easier to get to those gains. But all right, I just thank you for your time. I just wrap up there. I'll just quickly share sort of our next next webinar coming up in a few weeks' time on why mine electrification is more complex than anyone's telling you. So that's September 23rd. From Dr. Ali, I'm trying to remember pronounce his name, but Purmasavi from Uni of Adelaide. Done a lot of work there on the mine operational vehicle project. Be interesting presentation following on from this one. So thank you, and we'll follow how you go in the future with those bringing down your emissions.
Sure. Feel free to reach out if you have if some question pops up later, and I will share the presentation. Thank you all very much for your attention.
Thank you.